I know that 2 squared equals 4. I know that 2 to the third equals 8. But if somebody asked me what value of x would make 2 to the x equal 6, we currently don't have a way to do that other than guess and check. Just find numbers, plug them in, and see if we can make it get as close to 6 as possible. But in math, the way to actually do this is to use logarithms. We can use a logarithmic function to figure out what that x would be exactly. I'll be honest with you, I have no idea what's supposed to go in this first blank. I don't know. I really don't know. I'm an awesome teacher right now. The logarithm, this should say logarithm, not logarithmic. So again, awesome teacher right there. The logarithm of y with base b is denoted by log base b of y and is defined as followed. The log base b of y equals x if and only if b to the x equals y. The expression log base b of y is read as log base b of y. When you say log of y, y is the thing that is inside the log. The base is the small number that is in the subscript right next to the log. The first thing we're going to do is learn how to change between logarithmic and exponential form. I'm going to write this out again over here. Log base b of y equals x, and b to the x equals y. And I'm going to teach you the logride. To figure out how to translate between logarithmic form and exponential form, I use the logride. If you go to Worlds of Fun, you go on the logride. You go down the big hill, you splash into the water, and then it curls around and goes under, right? That's how like all log rides are designed. So we start with the base. So log base b, we're going to do the log ride. Woo! From the base to the other side of the equal sign and then back around. I call that the log ride. Some teachers are super enthusiastic and they have an actual log that they hold up above their head and scream, log power! And like, I'm not going to do that. I'm not quite that enthusiastic. Sorry. Okay, now, when you do this, here's why I do this little curly Q thing. If I start at the base and curve around, do this log ride, notice over here, b to the x equals y. That little curly Q helps you to see what order you're going to write things. So, b to the x equals y. You can also do this curly Q on exponential form. So, start with the base b. Woo! B log base b of y equals x. The logride helps you see what order to put things. Now let's actually use that. So log base 3 of 9 equals 2. We are going to rewrite that in logarithmic form. So start with the base 3. Woo! The woo is required. Did I not tell you that? I'm joking. You don't really have to. Okay, so 3 raised to the 2, and then come around, equals 9. The logride helps you to see what order you're going to write those numbers. It's just a visual aid in how to write them. Here's another way that some teachers teach this. Base raised to the exponent equals answer. That's what you're used to. Base to the exponent equals answer. The logarithmic version would be log base answer equals exponent. So those are other ways to learn how to transfer between the forms. Number 2, log base 8 of 1 equals 0. Start with the base. We need to do the logride. Woo! So 8 raised to the 0 equals 1. I would like you to try number 3 on your own. Number 3, log base 5 of 1/25 equals -2. Start with your base. Woo! 5 to the -2 equals 1/25. Okay, everyone good? Now let's do the other way. We're going to start with exponential and change it to logarithmic. Again, you can use the log ride. So start with the base 6. This is base raised to an exponent. So 6, woo, around the equal sign and back. Log base 6 of 36 equals 2. Now, math teachers are going to be very particular about how you write this. And it's not because we're mean and particular and OCD. It's because if you write this incorrectly, it means something different. So I'm going to write this in red because it's wrong. Do not write this, just look. That is that actually means log base 10 of 6 to the 36 equals 2, which is not what we're trying to get. So that is not right. Please make sure when you're writing your logarithms, the base needs to be smaller and subscript below the log. And the 36 needs to be the same size as the log and in line with that log. So see how log and 36 are in line with each other, and 6 is the subscript below. Make sure you write it that way. I will count it wrong on a test if you write it incorrectly. Try number 5 and number 6 on your own. The next one, our base is 16. Woo! So log base 16 of 1/16 equals -1. When there's a fraction inside the log, it can be helpful to put parentheses around the fraction just to make sure that it's all inside that log appropriately. Number 6, woo! Log base 125 of, woo, I made a mistake there. Woo-hoo. Of 25 equals 2/3. Okay, one more. Do you see how this next one that I wrote down, 25 equals 5 squared, do you see how I wrote it with the answer on the other side of the equal sign? When you do the log ride, the important thing, start with the base, go to the other side of the equal sign. So we don't always have to do that curly Q to the right. We can also do that curly Q to the left. So start with your base. Woo! This is log base 5 of 25 equals 2. That will be important for later. This is something that basically I'm going to ask you to do this once and only now. This helps you to see the connection between logarithms and exponential functions. So log base 3 of 81, we want to know what that equals. So start by putting that equal to x and changing forms. 3 to the x equals 81. Now, what number should that x be? I know that 3 squared is 9. 3 to the third is 27. 3 to the fourth is 81. So the answer here is 4. Now, here's the deal. You don't actually have to do this guess and check. We have these fancy calculators where you can do alpha window and do log base 3 of 81, and your calculator will tell you that it's 4. Or we also know the change of base formula. If you do log of 81 divided by log of 3, it will tell you that the answer is 4. But this just shows you how the log base 3 of 81 is connected to 3 to the fourth equals 81. So let's do number 9. We'll skip number 8. If we put this equal to x, 4 to the x equals 64. I know 4 squared is 16. What's 4 to the third? 4 to the third is 64. So the answer here is 3. This next part is a test question. And I may make this a bonus test question so that those of you who are paying attention right now get the bonus points, and those of you who are not paying attention don't get them. Every time I put this question on the test, when I read the answers, First I roll my eyes, and then I start beating my head against a concrete wall. The question is, what is the difference between a common logarithm and a natural logarithm? The answers that I get are, a common logarithm is the kind you use all the time, and a natural logarithm occurs naturally. That is not the right answer. That really makes me want to bash my head against a wall. Because here's the answer. A common logarithm is base 10. A natural logarithm is base e. What is the difference between a common logarithm and a natural logarithm? Common log is base 10, natural log is base e. So, if you see log of x, do you see how there's no base shown there? Once it pops up on the screen. Do you see how there's no base shown with log of x? If there's no base shown, that means it is log base 10 of x. If you see log with no base, that means it's base 10, it's the common log. If you see ln of x, ln means the natural log. ln of x is the same as log base e of x. So anytime you don't see a base, if it's log with no base, it's base 10. If it's ln with no base, it's base e. These are the buttons that are on your calculators. So even if you don't have a fancy graphing calculator, all you need is a regular scientific calculator. So in your calculator, punch in log button 5. Isn't it 0.7 when you round it? And then try ln button of 0.1. Negative 2.3.